I have taken a lecture. Name is Motion. Yes, that is what we are going to explore in details as much as I can tell you about it. We were discussing about this lecture in the previous lecture, in the previous lecture. But you might be thinking that then why are we discussing again in this slide, not something else? So I would like to say the name is the same from the previous lecture, but in this slide discussion on this will be at next level from the previous. Here something we will pick up, some words we will pick up from the previous lecture to the connection with this lecture. Some words we will take so that you can revise, so that I can tell you again, so that I can connect words from the previous to this with this lecture. Let's begin. This is going to be uh, uh, lecture, okay, chapter you can say. First, as you can see, reference point. Reference point is said. It is reference point is very important. It is considered very important. What I am saying. What I am saying. Look, without reference, you cannot tell position of any object. Object can be you, object can be me, object can be human, object can be living things, object can be non-living things. Okay, I am dividing objects into two parts. First, living things, non-living things. So object can be living thing, object can be non-living thing. Okay, yes. So we take you will take reference point. Why? There should be reason. Whatever you are studying, there should be reason. Okay, you are watching me. What is the reason behind why are you watching? Because of you wanted to gain information regarding this lecture. That's all. So this is the reason. Reason can be more. Your reason can be more regarding this. Why are you watching me? You can say yes. Reasons can be more. It depends on you, and it is not your reason that uh, I am interested. My career is related to this chapter. That's why I am watching. This maybe your reason, but this reason, your reason cannot be for other person. Cannot be for other person. So your reason and the reason of other person may be different. May be different. Okay. That person will have other reason of why is he watching me in this lecture. You can have something else reason. Something else reason. So let's come to the point. Reference point. To remember what we will take. Somebody will take a reference point so that that person can know what is the position of any object. You want to know. You want to know position of this board. What is object? Position of a house. So you will take another object. You will take another object as a reference point. For example, okay, we can take an example of a house. Okay, house. It exists in a real life. It exists. This example exists in a real life. That's why I have to I have taken house. House is an object. You are clear. Why are how to find the position of a house? How to find the position of a house? House. So you will take what? Let's say I am taking a reference point. House is where? Where? What is the location of a house? So you can say uh, 12th near in front of a college. You can say in front of a college is my house. Otherwise you can say in front of a college is a house of this person. In front of a college. So college. I didn't ask you what is the location of a college. No, I asked you what is the location of a house. And let's say location of a house is in front of a college. So college we have taken it as a reference point so that we can tell our location of a house. Okay, and now we have told location of a house. That person who wants to go to that house, then now that person can go easily. Okay, because we have told location. This person will go. This person will go to the college, and then this person will look what college. This is college. In front of this college, this is how. Oh, this is what is a house that I want to know where I want to go. So that is how most people find the location of a something, location of a house, not only house, location of a college, location of a house, location of a airport. There are a lot of things to find location of something. So reference point is taken to find location of anything. Location of anything. Okay. Reference point will be also what? Object. But this object will be something else. And whatever we want a location of something will be other object. Will be other object. So we will have two object. We will have two object. Reference point can be changed. Can be changed. Okay. Can be changed. So in some words you can remember this. Reference point is used to tell location of something. Okay, position of object, position of a house varies, and a reference point is a just object. Okay, is a just object. For example, this is college, and this is house. Okay, this is house. We can also say that we can also say to the to person that just you go this college, and then just from distance would be I think 100 meter you can say. No, 500 meter. You go 500 meter. Just you go this college, and then from the 500 meter from the college will be what? This house. So this is how much? 500 meter distance meter. So we can we tell what location of a house, location of a something by telling what? By telling distance. What will be distance between the reference point and main location. Okay, reference point and other object. That is all. There are some ways to identify to find a location to location. There are some ways some way to tell position of something. But you also take this reference point, so you are clear. Now let's move ahead. Rest and motion. Okay, rest and motion. Rest it means rest is rest is saying anything, anything is not moving at all. Anything is not moving. Fan, which is in my house, is moving, so it is in motion. Uh, this body is not moving at all. This this body is not moving at all. So this is in rest. I am moving. I am moving. So I am in motion. Now look, we will also take time. Object, object. Okay, let's say this is what. Okay, this is what. Time is passing. Time is continue. Time is a passing, but board is not moving at all. Time happened how much? 1, 2 seconds, 3 seconds, 4 seconds, 10 seconds, 20 seconds, 30 seconds, but it didn't move. It didn't move at all. After 10 seconds, after 20 seconds, nothing. Okay. So here we can define it by saying any object is not moving with respect to time. Time is passing, but object is not moving. So that object is in rest. Will be considered as rest. Rest is object is in rest. Now, what about this? Fan is moving, but here you can observe time. Easily you can observe. Yes, and here remember, we are not understanding something is moving or not. Okay, we are understanding it, but we will take also what a time. Time will be more important in this discussion. Okay, in this discussion. Okay, also we will tell what a time. This fan moved. Okay, this fan moved within this time. So like that we will be solving some questions. So here you will observe time, but you have to observe. Okay, you have to observe. We are able to observe that fan is moving, but we don't say that time is also moving, time is also passing, but we don't observe. We don't realize. We will have to realize when we will be solving question. So here fan is moving, time is also moving. Okay, so we can say this is in motion with respect to time. This also you can say hand of minute hand of clock is moving with respect to time. This fan is also moving. This fan is also moving with respect to time. With respect to time. Otherwise, you can say according to time. But instead of saying according to time, you can say what? With respect to time. With respect to time. If this fan is moving, then also time is passing. Okay, both are equally moving. Both are equally moving. Time is passing, then this is also moving. Time is passing, this is also moving. Time is passing, this is also moving. That is what is motion of something. Okay, let's say this. I moved this object, and now from here it came from here to till here in 1 second. It took also time. So motion will take also time, but first will not take time. Now, it is said that motion is always relative, not absolute. Relative. It is said. Means, one example I would like to tell you. One person is on a road, but two person I know it is not perfect. It is not a perfect. Two persons are in what? In a car. Okay, in this vehicle. Two persons are in this vehicle, and this person is outside from this vehicle. Now this both person, you can say driver of this vehicle, will realize that this person is moving. Driver will realize that this person, which is not actually, this person is not moving, you also know, but driver will feel that persons that are surrounding, that are outside, that are on road are moving, that are on road are moving. So who will feel? Driver will feel. But actually those persons who are on the road are not moving at all. So that's why it is said that motion is relative, because motion does not tell exact motion of something. Okay, appear, what did you hear? Appear, what did you hear? Now there are two persons inside this vehicle. This first person will realize that driver is not moving. Driver is not moving. Observer, this is observer. This is, let's just say this is A person and this is B person. Let's assume, okay. B person is a driver of this vehicle. A person will realize that B driver is not moving at all. But observer, this is observer, okay. This is observer. We have taken that this is observer. According to this person, driver is not moving at all. But what about if this person is observer? Then we can say B driver is moving. Driver is moving. Driver is moving. Okay. Driver is moving. So here observer word. Something is moving or not, we have to ask who is the observer. Then we can easily say that yes, this is moving or not, something is moving or not, object is moving or not. According to observer we can easily say. Okay, otherwise we don't know observer, we can get confused. Okay, something will be in motion, but we will feel that no, this is not motion, this is not a motion. Something is in a rest, but we will be confusing that this is in rest, this is in motion, this is in motion, this is in rest. Like that we can get confused. That's why it is said that motion is relative, not absolute. Not absolute. We are understanding what? Observer. Here who is the observer? From this example, we have taken this A person as an observer. Okay, as an observer. Now we can easily say, I asked you, I wanted to ask you, now tell me, if person A is observer, then tell me person motion of a person is person B moving or not? If observer is A person, then you can answer easily with logic. You would say no, both are inside, in rest. So that's fine. So according to this observer, person B is in a rest, not in motion. But second question, okay, you are correct. You have answered correct. Now, forget this, forget this observer. There are two persons and who are sitting inside this vehicle. Now take this person as observer. Now tell me, uh, tell me, both are moving or not? Both are moving or not? Both are in motion or in rest? Tell me, if this is observer, then you would say both are in motion. Both are in motion. Vehicle is moving. If vehicle is moving, Kishan is also telling you that vehicle is moving and both are inside the car. And now you have to tell that this is given as observer. Then you can easily say if a vehicle is moving, both are inside the car, so we can say both are in motion, not in a rest. That's it. That's it. We have understood observer, reference point, rest and motion. What else? What else? What else? This was enough, I think, for understanding of observer, for understanding reference point. Let's move ahead. Now next is interesting. Something else. Next is something else. Distance and displacement. Distance and displacement. What's the difference between? Before we move on difference between them, first of all we have work. What we have work? We have to understand definition of both words. Then we can easily tell what's the difference between them. Look. Distance is what? It says that distance says that I I show what distance show what total total length total distance covered by something can be anything, something can be vehicle, something can be non-living thing, something can be living thing. So it will give us what total distance. Let's say uh, you were here, okay, you were here, you went here, then here, then here, and then here, then here, then here, and finally you stopped here. Okay, you were here and you traveled like that, and you stopped here. Let's say that this is A and this is B. Okay. Like that states, have you ever experienced, have you ever seen like that states? Yes, it is very familiar. Yeah, isn't it? Sometimes you go like that, okay, like that, and you have to reach here, okay, and this is your street in your area. You will start from here like that, like that, like that, and you will stop here, isn't it? Yes, yes. Now you will measure you can use a device, you can use your mobile device to find total distance from here to till here, and mobile will easily tell you with the correct information. And you use what mobile device to find distance from here, and mobile device tells you what how much, let's say 22 not centimeter, uh, let's say 5 kilometer, okay, 5 kilometer from here to till here is how much. This is a total distance. Total distance. Total distance covered by you. Covered by you. Covered by you. This is 5 kilometer total distance covered by you. So here you are telling that total from here like that till the here total distance. But displacement tells you will tell displacement from here to till here direct like that, direct, not this that, okay, not this that, direct. So test distance, this, okay, this is the distance, okay. You won't say that this is a displacement, this will be, so it will tell you what total distance, but it will not tell you total distance. Instead, so test distance, clear. This was one point for in both the words. Now here you can say, if you are telling that only 5 kilometer and you don't know what is the direction, and you or you are not telling any direction, then we will consider this as a magnitude, okay, this as a magnitude, because you cannot have a direction, or you don't want to tell a direction, you are telling only one word, number. And now value can say value 5 kilometer. Here we use kilometer, which is a unit, and it is used so that we can tell what are we saying, what are we doing. We are measuring. Kilometer is telling that we are measuring we are measuring distance, okay, between 2 points. So these units are very important to say something, okay. Only 5 you will use, then it will not make any kind of a sense. That's why you have to use units. Units can be, but units are used according to what? According to rule, you can say. For liter, for volume, we use what? Liter. For volume, for liquid material, we use what? For liquid material, we use liter. For distance, we use meter, kilometer. Okay. Yes. For time, we use what? Second, minute, hour. Okay. So these are units. Now 5, here we are talking what? A distance between 2 points, which is 5 kilometer. You have only 5 kilometer. It means you are telling value. You are telling value of distance between 2 points. So it is just a magnitude, not a direction. When it comes to direction, it means you are telling direction with value. 5 kilometer, I have traveled today 5 kilometer in this direction. We can say in a north direction. 5 kilometer. So here you are telling what? Magnitude. In other word you can say value. Okay, value. Magnitude with the direction. And you will study based on this in the next level more. Okay, more. You will study based on this more in the next level. So remember, distance only will tell you magnitude, but displacement will tell you direction with the magnitude. Okay, from here to till here is how much? Let's say 2 kilometer. But in which direction? 2 kilometer in, let's say, north. In north, like that. We are not just talking this. We are talking this is shortest part, which is a displacement, and we are telling 2 kilometer. 2 kilometer is a distance of this displacement, not this distance. Okay, 2 kilometer is a distance of this displacement. Clear? And this is 2 kilometer is in north. Now clear. Clear. What else? What else? What else? Now, if what is the only magnitude? What is the what is the only magnitude? Then we say what this is a scalar. This is a scalar. A scalar. If what is the magnitude with direction? It means vector. Vector. Okay. It means vector. Vector which means vector is a quantity, you can say it is a quantity, but it will have both the things. It will have both the things. Direction with the magnitude. But a scalar is also quantity, but it has only magnitude. It has only magnitude, not a direction. That's all. So here we are saying magnitude is a scalar. Magnitude with a direction is what definition of a vector. Then we are saying, it means we are saying distance is a scalar. Distance is a scalar and displacement is vector. In short, we are saying, okay. Yes, it is a universal truth, the distance, because the distance is telling only magnitude. That's why it is a scalar. Displacement is telling what both the things, direction with magnitude. That's why displacement is being considered as a vector. Now next thing, apart from this, what can be? Yes, next thing is very important. Yes, is very important. It is, you can say, it is a test, you can say. Look, distance always will be in positive. It will be in positive, okay? In positive, you can say, in positive. It will always be in positive. But when it comes to displacement, I am telling you again, we will have a lot of concepts based on this. You will realize a displacement, you will realize vector, you will realize a direction in upcoming standard, when you will go to the next standard. So here, distance will always be in positive, not in negative, okay? Not you can say 0. If there is a 0, what are we telling? Nothing. What are we telling? Nothing. So here, displacement, it can be negative, 0, positive. From this, you can understand what is this trying to tell us. What do you think? It is the same, negative, 0, positive. It means direction. Let's just say object is here. It means we can say from the reference, position of this object is here. From this reference is 0. So we can say, okay, real example I would like to take. This, let's just say this reference point is here. 0, we are taking it as a reference point. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. As you know, this left sides are in negative. These numbers that are in right side from the 0 are always in positive. Now here, I am saying that the object is here. I want to know location of this object. Somebody would say that somebody knows position of this object, and I want to know from that person. And that person will tell me that position of this object. Just go to the reference here, and uh, he can also tell me directly what -3 is the location of that object where you wanted to go. So I will go where? First of all, I will go to the reference point, uh, then to the -3. This is -1, -2, -3. This is my location. This is my location where I wanted to go. Let's say this is the house of my relation. So here I wanted to go. I don't know what is the exact location. That's why I was asking. From that person. So here, that person can also tell me just to go to this reference and from left side -3, go to the -3, and -3 is the exact location of your relation house. So I will finally reach it here. So location of this object is where? At -3, and this is what a reference point. Object can be here, anywhere. Now this one. So here, all these are telling what? Direction. Negative this, but positive. It is not. It will not tell you direction. Okay. Can we move toward? Now next thing next thing is the a speed. Okay, a speed. What is the work of a speed? Okay, we say a speed. So what is a speed saying? Can you tell me? What is a speed saying? What is the work of a speed? Look, I can say it shows what a speed, or it something is faster or slower. Faster or slow. Something is fast or slow. Who will tell? Speed will tell. Okay, a speed will tell. A speed is defined in vehicles. A speed is defined in vehicles, as you know. A speedometer, you can see what is the speed of your vehicle on a speedometer. A speedometer tells you a speed of your vehicle. Odometer tells you what I how much distance I traveled by this time. So odometer will tell you this, but a speedometer will tell you with how much speed I am driving. I am driving my vehicle. So the vehicle speed. This is what will tell you. Okay. So in some words we can say a speed will tell you what this object is fast or slow. Let's just say we have two objects. It is going like that, and it reached here. You can say it we have decided what? A fixed location, like that. Okay, and this both vehicles have to reach to till here. Distance is equal. Distance of both travels are equal. Let's just say this is how much? 135 kilometer, and 135 kilometer is for also this. This is also 135 kilometer, and both started traveling. It reached here. This vehicle reached here within you can say 2 hour, 2 hour not, 1 hour, 1 hour 35 minutes, 1 hour 30 minutes. This vehicle reached to till this place with in 1 hour 35 meter, and it traveled how much? 135 kilometer. Now this second, it traveled how much? 135 kilometer distance, but it reached to till here within a for, you can say 50 minutes, 50 minutes. Now from this discussion, you observe something? A speed, a speed, a speed you can observe. You are observing it. Distance of both travels are same, and both are taking how much time? Which one? Which one? Which one vehicle is taking less time? And if one vehicle is taking less time, so we can say that vehicle was moving in fast, was moving faster. That is how we tell a speed of a object, a speed of a object. That is how. So it reached total here within a 15 minutes, and it took this vehicle took how much time? More, 1 hour 35 minutes. It took more time as compared to this time of this vehicle. So it took less time and it took more time. So we can say the speed of this was high, was faster. The speed of this was slow. That's why it came here. It took a long time. That is the way to tell speed. So work of a speed is to tell what? Work of a speed is to tell what? Fast or slow? Fast or slow? Fast or slow? Are you clear? Now, what about average speed? Average speed. What about average speed? What do you think? Formula is what? U plus B upon 2. U plus B upon 2. Where U is the initial speed. Where U is the what? Initial speed, and B was final speed. Here we are talking about a speed, not a position. Okay, a speed, because here average speed. So here, look at here. U is the initial speed of something, of one object. You can say yes, one object. Yes, one object. And V is the what? V is the final. V is the final speed of the same object. And we will add both, and we will take what? For example, you can take a example. You can take one example. What you can understand by an example. It is saying we have taken this. Okay, this. We have taken this object. A speed of this, it started with a speed of let's say 0. It will start with a speed of 0, and now let's say 15 meter per second. meter per second. Here remember, formula of a speed is what? Distance upon time. Distance upon time. Something covered distance will cover within a time. That's why time came here. So if a speed is equal to distance upon time, so time will be what? Time will be equal to distance upon a speed. Distance will be a speed multiple time. A speed multiple time. Okay. So here, if we now a speed is equal to distance upon time, so you can say distance will be equal to a speed multiple time. Speed multiple time. Here, if a speed is equal to, then you can say time will be equal to what? Distance upon a speed. So we have found what? More formula from this. Okay. Time will be equal to distance upon a speed, and distance will be equal to a speed multiple time. To find out distance, we will use formula what? A speed multiple time. To find out the time, we will use what? Distance upon a speed. And to find out a speed, we will use what? Distance upon time. No, we were talking about this. So this one object, this one vehicle started with a speed of 15 meter per second. 15 meter per second. Always remember, distance is measured in meter, and time is SI unit of time is what? Second, and SI unit of distance is what? Meter. So it will be what? Meter per second. Per, because of here we are applying per, which means meter upon second, and this is meaning of this. Now here it started with a speed of 15 meter per second, and it will stop with 0 meter per second. So this was what? Initial speed, and this is what? Final speed. We will take what? 15 plus 0 upon 2. So 15 upon 2. And we will divide it. We will divide it. We are getting 7.5. This is what? A speed, average speed of this object. This is average speed of this object. Average speed. Now here, what will be dimension of an average speed? So for this dimension will be same. Unit for this will be same. Meter per second. We will take this formula for a question based on this, so that we can practice. We can have clarity. Okay. Till here, just understand average speed. To find out average speed, we have to use what? Initial speed plus final speed upon 2. Initial speed. And to find out speed, we will use what? Distance upon time. To find out distance, we will use what? We will apply to find out distance. So we will apply a speed multiple time. To find out the time, we will apply what? Distance upon speed. Distance upon a speed. Clear? Okay, this is clear. Now let's, I think, velocity. We will understand velocity, acceleration, momentum. These are words that we have to explore in this. Yes, next is velocity. Next is velocity. Meaning of this word: a speed with direction. If a direction, what is the coming? we can say velocity is, if a direction is coming for velocity, we can say velocity is a vector. It is a very easy to identify which velocity is a velocity is what, a scalar, or velocity is a scalar, or is velocity a scalar or a vector. So it will be very easy when you know that word will come, direction word will come for velocity, then we can say velocity is a vector because of a direction word is coming. Okay, velocity as spread with the direction. It is what, velocity as spread with the direction. So what's the difference between velocity and displacement? What's the difference? Velocity and displacement. Look, displacement. Displacement was saying it will have what? It will have a distance, not a speed. It has a distance, not a speed. But velocity has a speed. Velocity has a speed. Both has a direction. Carefully observe. Carefully observe. Both has a direction, but it does not have what? It does not have a distance. Instead, it has a what? A speed. It has a speed, but a displacement had what, a distance. This is what is the difference between them. Clear? So there is a user difference between a speed and distance. There is a user difference. Clear? Both are vector because of both has a direction. Both have a direction, but displacement has a distance, and velocity has a speed. Okay, this one. Here, let's explore velocity. Formula of velocity is what? Formula of velocity is displacement upon time taken. Upon time taken. This is what? This is a velocity. It is a formula of velocity. Try to understand. Try to understand. You can get confused, but you don't have to. You don't have to confuse. Velocity will have what, displacement. Velocity will have a displacement. It is also direction. It has a speed. So a speed. Time will come. I think time will come. A lot of time for other words. Velocity, it is saying velocity, to find out velocity, it is equal to displacement upon time taken. How much time taken? Hold on. One object. Okay, one object. This is a displacement from here to here. How much? 15 kilometer. This is the distance of this displacement. And time taken is 30 minutes. 30 minutes. So can we say 15 upon 30? It will give us what velocity? It will give us velocity. 3 5s and 10 3s. That is how you will find velocity. Clear? This was formula of velocity. Next, Next, let's understand next thing. We will do some questions based on velocity. If you didn't understand meaning of this, yes, I know I explained just a formula, not a meaning. Even I don't know exact what will be meaning of this, but I can guarantee that I will explain meaning of this velocity with questions which will be based on this. Then just here you understand what is a formula, and it will have a displacement. It will have a displacement. Okay. Next is uniform motion and non-uniform motion. Next is uniform motion and non-uniform motion. Uniform motion. Non-uniform motion. Look, look. Look. We have a object. Okay, we have a object. We have a object. This is a object. It starts from here. It starts from here, and it came here. It came here. It traveled. It traveled with a distance of let's say 45 kilometers within a 20 minutes. Within a 20 minutes. Okay, and again it is a continuum. This vehicle is a continuum, and again from here to till here it traveled how much? Again 45 kilometers within a 20 minutes. Within a 20 minutes. It is again continue from here to till here. It traveled with a distance of a 45 kilometers within a 20 minutes. Within a 20 minutes. Again 45 kilometers within a 20 minutes. In this language, you can say, in language of physics, in a language of physics, you would say that vehicle is with a constant speed. Vehicle is with a constant speed. Okay, he is not changing. He is not changing a speed of a vehicle. Of his vehicle. He is not changing of his. He is not changing a speed of his vehicle. He is moving with a constant speed. With a constant speed. Constant, which means equal. With the equal time. With the equal distance. Distance is equal after some time. Distance is equal after some time. From here 45 kilometer, 45. So after some time, after 20 minutes, it is covering 45 kilometer. Again after 45 kilometer, it is again covering 45 kilometer within a same time. So till here it covered same distance after 20 minutes. After 20 minutes. So it is the same. This vehicle is moving with a speed with a constant speed. With a constant speed. You can say that motion of this is what? Uniform motion. No. How to identify? How to define this uniform motion? You can define it by saying if distance are same, equal distance are being covered with equal time, with a equal interval time. Interval will be better to say. Interval time. Interval, which means from here is what? How much? 20. So this is 20. This is 20. This is 20. So 20 is the interval time for this. So same distances are being covered within a same interval time. Will be what? Uniform motion. So you can say same equal distance with the equal interval interval time interval time. Okay, this is one point. But in this case, what will happen? Distance will be changing. Distance will be changing. Yeah, time can be equal interval time. Time can be equal after sometimes. So all times will be equal. But the distance is changing. Distance is changing. You can say this is covering 46 and this is covering how much? Let's say 50, 45, and again this is a 60. So here time is the same. From here time is a 20, and from here same time. From here same time. From here same time. But the distance is changing. Distance is changing. Here it covered from here 46. It covered from here 50. So distance are changing. So something is changing. Something is changing. So we can say if distance is changing, distance is not equal. If a time is changing, we will consider that example as a non-uniform motion. Non-uniform motion. Okay, non-uniform motion. Clear? Yeah, it here distance can be what? Distance can be equal. Distance can be equal. But here time will be something else. Time will be change. Time will be change. Like that. Time is a changing. Time is changing. These are a difference between uniform motion and non-uniform motion. Now next thing, is what? Acceleration. Accelerator is used. Why? Why is accelerator used? Why is accelerator used? Why is given accelerator in vehicles? In vehicles? Why? Tell me reason. I want to know. I want reason behind giving accelerator in the vehicle. What will be reason according to you? Work of accelerator is what? This is my question. Work of accelerator is what according to you? Now let's come to the topic. Accelerator will help you in increasing the speed. In increasing the speed. In decreasing the speed. Yes, you heard is correct. You can increase a speed by pressing the accelerator button. If there is an option uh, with of accelerator button, then you can press one. Otherwise, like that, rolling. By rolling accelerator, you can speed. You can increase a speed of your vehicle. You can increase the speed of your vehicle by a rolling accelerator. Okay. So rolling accelerator, I think it is found in two vehicles, no? Yes. So work of accelerator is to increase the speed of the vehicle, is to decrease the speed of the vehicle. This is what is work of accelerator. I think you are clear. You are crystal clear. Acceleration is what as rate of change. It is said that as definition of acceleration is what? The rate of change. The rate of change. The rate of change of the speed is the acceleration. Yes, it is correct. But it is a book language. Okay, it is a given in book. From our language, how can we understand this word? We can say we are increasing a speed. It means we have applied acceleration. We have used acceleration. We are using accelerator to increase the speed of the vehicle. This is what is work of this. Okay, you can increase the speed. To increase the speed, to decrease the speed, accelerator device is used. Accelerator option is used. It is found in vehicles. It is found in devices. Clear? Do you want to understand with an example? Okay. Let's say same vehicle. It is moving with a speed of 30 meter per second. 30 meter per second till here, and then it increase a speed of itself. With now from here, it started moving with a speed of 45 meter per second. Now this transition is the accelerator, is the acceleration. This transition is acceleration. So it increased the speed is acceleration. Okay. Now this vehicle wants to stop so it that's why he he decreased his speed because of he wants to stop his vehicle. So it he decreased with a speed of let's say 10 meter per second. Now this is what, if a speed is decreasing, we will say there is a deceleration. If a speed is being increased, is what? Acceleration. Okay, this is acceleration. This is what? Deceleration. Okay, I hope you understood something. How to find acceleration? In mathematical way. Look, velocity will have displacement, and acceleration will have velocity. Now tell me, what will be SI unit of this? If you have given this formula, you can easily tell. Change in velocity, meter per second, and the displacement upon time, So for velocity, what will be? Meter per second, I think, yes. It is a meter per second, and this is a second. It will go here. So I think meter per second square. Okay. So SI unit of acceleration is meter per second square. Velocity. If velocity is word coming, so velocity is found what a direction. So we can say acceleration is a vector. we can say acceleration is a vector. Now here velocity is trying to tell you is there is a acceleration in a specific direction. It can change the direction, it can decide the direction, it can move anywhere. That's why what that's why I think there is a word what velocity. Change in velocity. Where will it change? Change will be with velocity. Change in velocity. Uh, Something is moving with direction. It is moving, and it is something is a change in velocity. With velocity is what as acceleration, and how much it take, how much it took a time, how much vehicle took a time with increasing the speed is what acceleration. It is the same. Try to understand carefully, as I telling you, and you also try to understand carefully. It is the same. Vehicle is moving, and it changes what a speed. So there is a change in a speed. Of course, it will take a direction. He will take a direction. He will not say that I will go only this direction. It can change a direction. He can change a direction according to need. Okay, there are a lot of turns in our areas to go somewhere. There are a lot of turns. That's why vehicle will take a turn. That's why here we have vector, we have a direction, we have velocity, we have displacement. Okay, how much, what is a change, how much what is a change in velocity, and how much vehicle took time is what acceleration. In velocity we were understanding, in the discussion of velocity we were understanding that displacement upon time taken. So vehicle is going with the same direction, in a specific direction, and how much he took a time will be velocity. And displacement was what? Displacement was what? It will tell you a displacement was giving us what? A magnitude and only a direction. Magnitude with direction. And now velocity is what doing? Velocity is doing what? Velocity is the same. Displacement upon time. Yes, here you can see difference between them. Velocity is the same. What's the difference? Time is the difference. Displacement, it is not telling, it will not tell. Displacement will not tell you time. Displacement will not tell you time, but velocity will tell you time. With displacement. A vehicle covered displacement, but with how much time? Will be what? Velocity. Somebody is covering displacement, and that person took how much time will be velocity. This is the difference between them. Now, what's the difference between acceleration and velocity, acceleration and velocity. Here, here, if there is a change, there is a change in velocity, there is a change velocity, you can say there can be change in displacement, in displacement. If word displacement is changing, of course vehicle will take turn. Okay, according to need, vehicle will take turn. So then change will come. Then change will come in, you can say in a speed, in a speed you can say change will come. So change in velocity, change in velocity upon time, time will be same. How much time was taken, how much time was taken by that vehicle with the changing in velocity, with the changing in, it is the same. Acceleration is saying okay, don't worry, you can what you can increase, you can increase a speed of your vehicle. If you are getting later if you are getting later somehow, then you can increase the speed of your vehicle. I am not saying that you go with this speed, with this speed, it depends. Look, boss wants what, our product should be arrived with a proper time, with a proper time, not with unproper time. This is what boss wants. And vehicle driver of a vehicle will work of a vehicle driver will be what, to reach the product with to product to the customer. And now he will take what, some turns, he will take some turns, he will take time, how with how much time he arrived this product with how much time. So of course the vehicle will take time. So it is saying you can increase the speed according to need. If there is a traffic, you will decrease speed of your vehicle. Yes, it will happen with that vehicle, with that vehicle. So here with acceleration will tell you what was the change in your velocity, what was the change in velocity when you were driving, what was the change in velocity, how much acceleration you have taken, how much acceleration vehicle has taken with the time, taken. Clear? There will not be change in velocity, but here in acceleration there is a change in velocity, not in time, time will be total, how much time a vehicle took. There is a change, there will be change in velocity.